Yeah.
Benvenuti a tutti, grazie di essere venuti. Siamo a Bildo, per chi non sapesse, che è l'azienda dove lavoro con le persone che vedete qui intorno. Oggi è venuto a trovarci John da... What were you again?
What was I?
Yeah, before here.
Oh, where was I? I was in Berlin for Scala days.
Okay, from Berlin, because he doesn't live anywhere, apparently, or everywhere, I don't know.
Everywhere and nowhere.
Okay. So, well, again, thank you, John, for passing by and giving this talk, which is brand new, by the way, and I managed to miss it in Krakow, so I'm glad I can catch it again today. And it's about Fury, in case you didn't read the description on the meetup, and it's really exciting. So
thank you.
Let's get to it. Thank you.
Well, thanks, Gabriele, and thank you to Bildo for giving me this opportunity. It's nice to have a definite target where I need to have an interesting demo ready by, which is what I'm here for. I'm going to give a talk which I gave in Krakow for the tooling conference, and the focus will be I'll give a spoiler that the focus will be a new build tool I'm working on. But I'm going to talk a little bit about why and some of the problems with the ecosystem with Scala at the moment, as I see it, and why I've jumped on this bandwagon of building a build tool. So just to give a little bit of history of my experience with tooling in Scala. I started 14 years ago, and I was using Vim and Make to build Scala. I had a Make file. There was nothing else back then. So that was the choice I made, and I still use Vim. I still haven't jumped on the. I still haven't started using a proper IDE. But I would describe this currently between build tools. I've used a variety in the meantime, but I was using Make in 2004. Then within a year, I'd switched to using Ant to build Scala. Ant used to have the best Scala support of any build tool. Has anyone here used Ant? Oh, you haven't lived. but you haven't lived, but it's probably a nicer existence. Has anyone used Maven? So a few more people using Maven. And by 2007, I'd got bored of writing all the XML required for a POM file, and I'd written my own Scala-based generator, which would produce POM files from some Scala code I would write. That was nice for a while, about a year. And then I gave up and went back to Make because I actually understood how Make worked. For all the trouble that you get with writing a Make file. I didn't ask, does anyone use Make for anything? So, I don't know if it's equal to Maven. I haven't mentioned SBT yet, but for what is now a 30 or 40-year-old tool, it's still very popular. I think because it's quite simple. People understand how it works. And then that only took us up to 2008. The last 10 years, I've gone back and forth, and I've tried different things, and I've tried various hacks. Mostly I've used SBT because it does have the best support, and it is the most featureful build tool we have. But right now, I think there's a bit of a renaissance of build tools for Scala. Well, tooling in general, but especially build tools. SBT, as I said, is almost everywhere. It's the default choice. I wouldn't recommend right now anything other than SBT if you want to build Scala. Even though I don't like it. I don't like some of the design decisions that were made early on, and I've got all sorts of complaints. But practically, SBT is what you want to use for most things. Mill and CBT are new build tools which are getting a lot of work. Mill especially. And then Pants and Bazel are two other build tools which are, I think, used in Twitter and Stripe in particular. And Maven and Gradle still exist and will still build Scala for you. But I've been thinking seriously about build tools for probably the last 5 years. Just in my spare cycles when I'm sitting on a plane and my laptop battery's died and I need to work something out. And I've got into the mindset that there's some potentially radically different solution that could work better for us. Something that's not merely an iteration over the existing tools, but throwing out everything we've got and building it again from scratch without a lot of the complexity we've become accustomed to. What is my problem with build tools? Why do I think that there's a better solution out there? When there are certainly a lot of people who are very happy with SBT. I should ask the question. First of all, who uses SBT? So pretty much everyone. Who is happy with it? Don't feel obliged. So there's a lot of cautious hands. I'm sure you like it for some conveniences it provides, and then you remember the occasions where it doesn't do what you want it to, and it fails with the stack trace, and you just don't know how to solve the problem, and you end up copy pasting some code into your build, and your build gets much longer and it's harder to maintain. And so I'm starting to elaborate on some of the problems I experienced with SBT. In general, I think the builds we have are too complex. We have SBT gives us a Turing complete language. It's Scala, basically. We can do anything we want in the build, which means we have to compile it and then run it just to work out what it is we want to do in our build. On a related point, publishing binaries is very complicated. Has anyone successfully published to Maven? Maven Central, should I say?
At some point in time.
So at some point in time, was it really easy?
No, it wasn't.
Okay, nobody ever finds it easy. Some of the smartest people who write the best libraries for Scala get really stuck on this. And it seems like the documentation's not great. The process changes slowly over time as different plugins become in vogue or less so. It's painful, and actually I tried to do this in the presentation in Krakow, but I didn't have an internet connection. I actually wrote a game about publishing a library to Scala. Now this was written in about 2012, I think. So it's about 6 years old. Would you like to play? We'll take a 5-minute deviation. So you've written a great open source library for Scala. It uses type classes, the cake pattern. It's not such a good idea. A couple of macros, and you feel like it demonstrates your mastery of higher-kinded types and type constructor polymorphism, and you're generally quite happy about life. But you want to share it with your friends who want to try it for themselves. So how should you proceed? Either publish it on Sonatype or another service nobody's heard of. So votes for Sonatype? Another service? Okay, that had 2 votes. You're going to have to vote more willingly, but we'll go for the other service. Is this working? There should really be a link, shouldn't it? I'm going to try refreshing the page. It says waiting for the web address. Let's. I think the website that runs this this website has gone down. Yes.
It doesn't work in Europe.
Well, it's. Yeah, I have no idea. Well, okay. It worked better than last time, but it is in a way still indicative of the process of publishing. In that it basically doesn't work and you don't know why. So that's a nice little microcosm of the process or metaphor. Oh, it's loading. So we went for another service. Okay, right. You've chosen to publish software on a service nobody has heard of. Publishing was utterly trivial, but nobody has heard of the service, so it doesn't matter. So let's publish on Sonatype. So we've chosen Sonatype. Lots of people use Sonatype, so your software will become available to a wide audience. You go to Google and search for instructions on how to publish. The first result in Google looks promising, but there are other results too. Follow the first link, or try one of the other links at random. Random. I think if you just shout out, then I'll just pick whichever one we want. So you found the instructions, they're long and tedious. What are you going to do? I'm smart, let's just skim read them, or RTFM. Skim read. I think it has to be skim read, surely. You take a cursory glance over the instructions. You see fragments of Maven POM files and a whole ant build script. Remember, this is a build your own adventure built on real experience. This is what I did see in this particular link. But it's far from obvious what to do. Okay, let's just read the whole damn thing from the beginning. You decide to read the instructions from the beginning. It starts by suggesting there are just 3 simple steps, which is, and so on. I wrote a load of stuff here. I was so annoyed at my publishing process that I wrote this game. It was really frustrating me, and I couldn't get it to work, so I thought, I'll just write this game instead. At least everyone will be amused. In fact, I'm just recounting what the text actually says. While you're waiting to start writing a choose-your-own adventure game. Eventually you receive a response to a ticket from a kind Sonatype administrator, and you have a Sonatype account. Okay, let's carry on with the instructions. We've met a Scandinavian lambda troll. I think we'll just flat map that shit. So we flat map some shit. The troll quickly fades away, and we continue with the process. Instruction 4. Even the game is hard to use. So which should we use, Gradle and Maven or SBT?
Gradle.
Let's try Gradle. Well, no, you don't even need to read the text. You've never heard of anyone in the Scala community talking about Gradle, and there's probably a reason for it. Okay, another choice? SBT. Straight to SBT. 3 external references. Paul Phillips' page, Cake Solutions page, or the SBT repository on GitHub.
Has to be Paul Phillips' page.
Oh dear, this page doesn't exist anymore, if it ever did. But it was indexed on Google for a long time. Cake Solutions. There's a funny cartoon. They reference some plugin, but when you run it, it fails with a nasty stack trace. Okay. GitHub. So, when you try to run SBT, it fails. That's the same thing, isn't it? Let's, or maybe a slightly different plugin. So we search Google for something like SBT and so on. You found the SBT PGP plugin page on GitHub. It can't find a dependency, but I was actually sitting next to Eric Osheim when I wrote this, and he sent me a working SBT configuration. And you compare the configurations, but Eric's is working fine and mine isn't. So I'm getting desperate. Send a tweet to Josh Surrett. Does anyone remember Josh? Yeah. And that is more or less the end of the game. And at some point after this, I did actually manage to publish whatever it was I was trying to. But it wasn't quickly afterwards. It was, I think, about a year afterwards. The process back then was really horrible. It's now not so bad, but it's still quite difficult. I didn't even get into generating PGP keys and all of that. So that I need to. Oh dear. I just need to load. I closed down the entire browser window. Let's do this. is this? So I think half of the problem with building and the challenge we face is not so much with the build tool, but with the ecosystem as well. And publishing is difficult, which means that if we want to start using, for example, Scala 2.13, which is due to be released in late summer, early autumn, there's a gap between Scala 2.13 actually being released and us being able to use it. So on the first day, day 0, the new version of Scala is released. And then on day 1, the first thing that happens, and it's normally within a couple of hours because he's very much aware that this is his responsibility, that Sebastian Deren will publish Scala.js because everything depends on Scala.js. He knows that he is next in line to publish something. Scala test is also very heavily dependent on. So after that, when Sebastian has done his work, Bill Venners will publish Scala test. A few days later, Miles may get around to publishing Shapeless. A lot of things depend on Shapeless. Circe needs Shapeless. So Travis at some point will get around to publishing publishing Circe for Scala 2.13. And then maybe after a month or so, most of the commonly used libraries will have upgraded. That's a month. A month when, if you had all the sources in the same place, you could have done it yourself. I'm just putting that out there as a possibility. And then maybe after 2 months, that one little library, which is not particularly well maintained, gets published as well for 2.13. And then finally, the day after that, you can start using it. So there's a lag of about 2 months in this example. It varies depending on the project, how many dependencies it has, what the structure of the dependencies is. But doesn't that sound horrendous? We're waiting 2 months to actually be able to use some software which is released on a particular day, on day 0. And we enact various things to try to work around this. We sometimes create fat jars. We pull everything into the same project and publish that as a binary rather than waiting for other people to publish and then depending on them. We just bundle everything together. So we have huge jar files. Is one solution. Or we just copy-paste code from one project to another. I probably don't need to explain why this is a terrible idea. We do things to artificially minimize the dependency tree depth. So we try to reduce the number of levels in the tree that we have to wait in order to publish. Now this is sometimes maybe a little bit subconscious as to why we're doing it. We know that more dependencies are bad, but we've sort of become a little bit detached from the reason why we dislike dependencies. And we'll do things to generally try to avoid more dependencies. When actually, naturally, as programmers and functional programmers, we're seeking to reuse code, to minimize and modularize projects as much as possible. That's what we would, I think, naturally want to do, and instead we're sort of hacking it in different ad hoc ways to try to make things a little bit more pleasant, remove a little bit of the friction that's involved. We get less code reuse, less modularity, and the libraries are generally bigger. Bigger libraries are also bad, because if you have a dependency, or if one library provides some functionality you need, but also provides a whole load of other functionality that you don't need, you have to depend on the whole library. Now that increases the likelihood that you may get a diamond dependency problem, where your project depends on 2 other projects, which themselves both depend on the same project, but different versions. Now it might be completely different and unrelated parts of that same project, but it's a problem which you have to resolve. And the bigger that project is, the more chance, for example, if it's something like Scala Z, or Cats, or Shapeless, has different features bundled together in the same project, whereas we'd actually like to modularize it and depend on just the bits we need and remove some of the risk of having somewhere in our graph of dependencies a clash in the version numbers. But I think what's worse than this is that the whole ecosystem and the Scala ecosystem and the companies that use it, it must be a multi-billion-dollar industry by any measure. We have large banks depending on Scala. And they're depending on Sebastian Duren to publish Scala.js in order to get their work done. He's a PhD student. This is wrong, I think. We shouldn't be. I mean, what happens if Sebastian's on vacation when Scala 2.13 is out? Well, actually, what happens is he knows when Scala 2.13 is coming out, and he avoids taking a vacation that day. That is literally what happens. He told me that when he was in the audience when I gave the talk the first time. We're depending on like a small but non-zero number of key people, and any one of those people who is unable to do their publishing will hold up by a day, maybe several days, the entire rollout of a release of Scala. The whole ecosystem also depends on Maven Central. I know there are other services available, but we expect Maven Central to be providing most of the jars that we depend on. And another issue is because we're publishing binaries, we cross-publish everything multiple times for Scala 2.11, 2.12, soon to be 2.13. Then Scala.js, which has maybe another 3 versions. If you have a compiler plugin, that will have a different version for every minor version of Scala. So that's maybe another 20 versions if you're supporting Scala 2.11 and 2.12. Scala native. So we have what is essentially the same program, the same project being published many, many times. Like typically it's about 8 times. There's a sort of matrix of Scala versions and platforms. We're publishing the same stuff multiple times, and the process is slow for every single one of those steps. So I'm thinking about building writing a new build tool. I was a few months ago, and people gave me some advice. They willingly offered me their life advice on writing build tools. And it was almost universally this. Pretty much everyone said don't write a build tool. Does anyone remember Mark Harrer? He's the original author of SBT. We don't hear from him anymore. It's a very sad story. He got so much criticism from SBT that he's no longer involved in the community, and he's someone who provided a tool that didn't exist before, and which has become the #1 build tool for Scala, and he's effectively hiding from all of the users. One person though said, "I think you should write a build tool." That was Julian Dragos. I'm still not sure if he was trolling me, but I thought about his advice. And one other person, who you probably know, said, "That's an interesting idea. I think it meets my golden rule that if you're going to do something which might fail, I think I can tick the box that it might fail, then you should absolutely set out to fail in the most interesting way possible." That was Miles who said that. And I think I'm following that advice more than anyone else. So I'd like to introduce Fury, which is my new build tool. It's named after my experience with SBT. And I would like you to think of it less as a build tool and more as a dependency manager. It's managing your graph of dependencies rather than actually building Scala. However, it does also build Scala. So just to give you a few high-level design decisions I made in coming up with Fury. It uses source dependencies primarily. It will support binary dependencies, but it will primarily work off sources. It integrates with Git to do this. The builds are not going to be code. You can't run the builds. You don't need to compile the builds. They are simply data. And I'll talk a bit about what a build is later. An important, very important decision I made, and I'll tell you why later, is that the builds may be external to the sources. They can be in a different repository. That is going to be absolutely crucial later on. And consequently, the builds may be distributed as well. There's no central repository. Builds exist in different repositories on Git, so on GitHub, Bitbucket, or wherever you choose to have your code. And they're distributed rather than relying on one central point of potential failure. There's a public-private key-based trust framework involved. One thing that Maven does provide is it forces you to sign your binary. So I need to provide that same sort of trust. And the main interface to Fury is a command line interface. Other interfaces may be available later, but primarily the number one way you'll interact with it is through the command line. And tab completion is very important there. Does anyone know about Bloop? So a couple of people. Bloop is quite a lightweight wrapper around the Scala compiler that's been developed by the Scala Center, which guarantees there's a hot compiler running in the background, ready to take your build commands whenever you want them. And it ends up being quite a lot faster than SBT. So when I say that Fury is not a build tool, I'm using Bloop, which also claims not to be a build tool, to do the building. Between the two of them, I think they combine to form a build tool, but in isolation, they are they're independent and not really a build tool. So, source dependencies. The main purpose of this is to allow us to very easily depend on any version of code that is available to us through Git. And for building things, usually we don't need to have all of the complicated details that exist in a for example, an SBT build file. All we want to do is run the compiler on some sources with a class path, maybe with some parameters, and we want to get class files out of it. Now that will give us everything we need to do the next phase of compilation. The next phase of compilation doesn't need any of the more advanced things that a build tool can do. It just needs those class files so that it can do the next step. At the end of all that, when you've built a whole complicated graph of sources, you'll end up with a load of class files, and then you can start doing things like packaging them up, putting them into a Docker image, doing other things. But that's not what I'm trying to solve. That problem is dealt with by other tools. SBT does that. SBT can call out to Fury and say, build all this stuff, and then it can do the work later, like maybe connecting to a database, various other things. So sources are a very convenient way of defining our dependencies. We can define a reference to a Git repository. We can define a commit hash, and that is a specification almost of what we need to do the build. I wanted to make the builds data because it's very, very difficult to reason about what an SBT build does. For a start, a sort of minimum length of an SBT build is about 100 lines of code. And you can sort of look for patterns in those build files, and maybe you can see there's some submodules, and then you can find the dependencies between them. But you're reading code to get that information, and then you don't know if there's some subtle one line somewhere else which does something a little bit different from what you expect, or someone's written the build in a slightly different way, or they're using some plugins which change the way it's interpreted. It's far too complicated. If we represent the builds as data, we can do things like instantaneously get a complete overview of what's being built, or what our build graph is. If we remove the option of having dynamic builds, which inspect something somewhere along the way and then change what gets built dynamically based on something, then that saves us a huge amount of complexity for a small cost. Now, there's maybe a few builds I won't be able to represent in data because of this choice. That's something I've got to accept. It might be that those builds can be rewritten in a different way to support that, but I'm aiming to support sort of between 95 and 99% of builds out there. That might mean I need to add some more features to Fury to support some commonly used features in a data-based format. But at all costs, I want to avoid the possibility of having arbitrary code run that could do anything, that could connect to the network, could, I don't know, anything is possible with an SBT build. I want to avoid that. The builds may be external. Now, this I think is important not so much for individual users, but for the ecosystem as a whole. New build tools like Mill and CBT, they expect there to be a build file, much as SBT does, a build file which stays in the same repository as the code. And you clone the repository, you have the build file there, you run it. That means that if you want that repository to use your build, you have to persuade the author to accept that build as a pull request, or persuade them to adopt it themselves. It's really hard to bootstrap that, especially when I'm relying on the entire ecosystem, or large parts of the ecosystem, to adopt Fury and source dependencies and this new, easy to reason about build format. So by having the build files externally, I can write them myself. I can go home and I can write, I don't have a home, but I can go somewhere and I can write a build file for Shapeless. And I haven't got to persuade Miles to use it. I can just publish it myself, and I can refer to his repository. And I can refer to a particular version. I pick a tagged version. I can publish actually several different versions for different versions that Miles publishes, and I can maintain that myself. And my builds are quite a lot easier to work with. Remember, they're just defining a graph which chains together a sequence of compile phases. I can do that, I can publish it, and I can build Shapeless. And if somebody wants to depend on Shapeless, they can depend on the build I've written. Now, at some later date, Miles may think that my build is not adequate, and he'll think I'd rather take that myself and work on it. He can fork my build, and he can then say, he can make the changes he wants to make, he can adapt it for his own uses, and it's then perfectly reasonable for him to say, I've got a build as well, you can use my Fury build for Shapeless. And people may think, well, actually, I trust Miles to build Shapeless more than I trust John, so I'll go with Miles's build. I will depend on Miles's build rather than John's, and then maybe I don't have to maintain it anymore. But I think it's reasonable for me to pick a few of the most common projects, create my own builds for them, and do the little bit of work required to demonstrate how easy it is. And then all I have to do is persuade a small number of people to help me to build most of the other projects. I don't have to persuade every single author to adopt a tool which they've got no experience with, they've got no reason to adopt, they've seen no proof that it's better than SBT. It's much easier for me to make that case to a small number of willing people than it is for me to persuade everybody. That's my aspiration, to bootstrap the ecosystem rather than to simply sort of win a few builds here and there. It's distributed. So I mentioned already that Miles can fork my builds, anyone can fork anyone's builds, they can contribute back to them. But we're not depending on Maven Central. When you publish a build, you publish it to a repository which is anywhere on the internet that it wants to be hosted. That can be GitHub, Bitbucket, GitLab, or your own private Git server if you want. This means that if Maven Central or Sonotype goes bankrupt, I don't know what I don't want to spread any fear, uncertainty, and doubt, but I honestly don't know what financial stability Maven Central has. What happens to the ecosystem if they disappear overnight? I don't know. There's a trust framework. I mentioned myself publishing builds and, for example, Miles publishing a build. In order to publish a build, you have to sign it. You have to sign it with a key. And when you depend on a build, when one person depends on someone else's build, they will see who it's been signed by. Fury will tell them who has signed the build, who they are trusting, and they can go and check that on Keybase and see if it fits with their expectations. People may be more willing to depend on something that's been signed by a build that's been signed by the author of the project, rather than some random person on the internet. Some random person can still publish a build, in the same way that some random person can still publish a Docker image to Docker Hub, and people will still depend on those. But if you want to be careful, if you want to pull in those builds and republish your own, then you should be checking them carefully, because it is a network of trust that you are working within. And there is a command line interface with tab completion. I spoke about this at some length in the talk. I'm actually just going to give you a demonstration later, so I can explore this in some more detail next. Bloop was a project that came out of the Scala Center, which was designed to provide a nice command line wrapper around Zinc. Now, Zinc is the part of SBT that is somewhat independent, but does the incremental compilation analysis. Zinc is what guarantees that SBT doesn't recompile the whole world every time you make a change to one file. And Bloop is a very lightweight, a very fast, and a heavily optimized command line interface that will do the analysis, or use Zinc to do the analysis, and will hand over build files to a hot JVM. A hot JVM, one that's been warmed up with several compilations, can be several times faster, up to sort of twice, maybe even 3 times as fast as the very first run. Typically after 10 compiles it doesn't get much faster, depending on what you're compiling, but it is a significant increase over creating a new JVM with a new compiler every single time before Hotspots had a chance to optimize anything. I've got a funny GIF of this is Bloop in action, or a metaphor for Bloop. And then it's spinning up 2 hot compilers in parallel. It's ridiculously fast. So this data format, this model that Fury uses, has projects which correspond more or less to Git repositories, modules which correspond to sub-modules in SBT, So a project which has several phases of compilation, the phases would be modules. All the code would be together in the same project, which is a Git repository. More interestingly, perhaps, is the concept of overlays and universes. An overlay is basically a collection of projects. And when I was talking previously about publishing builds, you don't publish a build for a single project, you publish a build for a collection of projects. And if someone wants to depend on those, or on any of your projects, they can choose to pull in an overlay. And that pulls in those projects and makes them available for you to depend on. I'll show you a little bit more about that on the next slide. A universe is a coherent set of projects. Within a universe, a project name can resolve to, or must resolve to, a single version of the code. So with any dependency manager, there's always the risk that the vast tree of dependencies that branches off in many directions can have dependencies on two different versions of the same project. Now this is problematic when you're recomposing the class path from those projects, because they all have a shared namespace. So the shapeless namespace is the same for shapeless 1 and shapeless 2, but the code is completely different and it's incompatible. So if you have a project which depends on shapeless 1 and a project which depends on shapeless 2, and you depend on both of those, the class path will not work, basically. You'll get a linking error at runtime. Now there are solutions to it. There are various solutions. One solution would be, I don't know if I've got a slide on this. Maybe I'll wait, I'll see if I've got a slide, and then I'll talk about it in more detail. I spoke a little about overlays and universes. So, overlays are maybe best explained with some examples. So you maybe want to depend on some projects, or just one or two projects, in which case you would maybe look for an overlay for something like Magnolia, my generic derivation project, or Circe, or Scala test, or Shapeless. You would say, pull in this overlay and make available to me Magnolia, or Circe, or Scala test, or Shapeless. And then your projects can depend, or your modules can depend on those. But it might be convenient for me, for example, to publish an overlay that contains several of my projects, where I've gone to the trouble of resolving all the versions so that they're already coherent. They're already a universe. Even if at some point I had various diamond inheritance problems. Maybe Buildo would like to publish an overlay as well, or maybe they just keep it internal. So the projects you use internally, you have set versions maybe that you want to use together. That would be completely possible. Lightbend or Type Level might actually like to publish what could possibly be called a platform overlay, which is a more complete ecosystem of projects. The key thing is that if you import that overlay, everything in there resolves neatly. It's already uniquely. If you import the type level overlay, if it has Libra and Circe in there, both of which depend on Shapeless, you know, because that's a published overlay, that it will uniquely resolve to the same version of Shapeless, because it won't allow you to publish unless you do that. And this could actually make a great basis for the community build. So the community build is a sort of snapshot of all of the projects that exist in the Scala ecosystem, or as many as possible that exist in the Scala ecosystem, to test Scala compilations against with a new compiler. So we could totally put together a community build that contains coherent versions of all of the libraries that are in the current community build. And there's work involved for people to maintain these, to maintain the consistency, to upgrade things when they want to use a newer version, to fix the dependencies when dependencies get upgraded. This is ongoing work, and it's an evolutionary process as these overlays would be maintained. But throughout that process, anybody can fork the repository containing an overlay and make the changes themselves and send the pull request back to the owner of that repository, the overlay repository. The work is distributed amongst the whole community. It's not relying anymore on a few key people. If Sebastian Duren disappears for 6 months, the whole world can continue working because we can just fork his repository, continue to upgrade the builds, and everything can continue without being held up. So when you pull in more than one universe, say you pull in Lightbend and you pull in type level, there's a lot of projects in both of those. There's probably one or two that have slightly different versions and clash. And we have a few options on how we can fix that. You have to fix it if you're going to republish that combined combined universe. So remember, when each of these universes starts off, they are self-consistent, but when they're merged, we've entered the territory of possible diamond dependencies. In those cases, one thing we could do is just pick a version. If it's only a minor version difference, just pick one. Compile everything, see if it works. If it works, fine, keep it. If it doesn't, then maybe you have to think a bit harder. It might be that the projects that depend on different versions of the same thing don't use, or that dependency isn't used downstream of them. In which case, you can actually use package shading, so renaming all the links, all the references to one of those packages, one of those projects, so that it doesn't appear downstream and doesn't clash. You don't have the possibility of interoperability between them, but it would be completely possible to package shade one or both of those dependencies, and you could proceed, and everything would hopefully work. Or you might want to you might need to do a bit more work in order to get things working. Say you have some API changes. One project is using a more recent version of say Shapeless. Let's say Shapeless 2.0 and 2.1. There are some API changes there. But you really want to use both of these projects that depend on these two different versions of Shapeless. One thing you can do with a single command in Fury is that dependency that depends on the old version of Shapeless, you can say, well, fork it locally. It's one command, you specify the directory you want to move it to, and that is now within your control, and you can go and fix that old project that is depending on Shapeless 2.0, and you can manually upgrade it to 2.1. Now, rewriting other people's code is sort of a last resort, but it makes it possible where it wasn't possible or wasn't simple to do before. You can carry on depending on that forked version for as long as you like. It's one possibility. You can create a PR later that same day, send it back to the project, and the author has now benefited from the ease with which with which you can contribute back. And once that's been accepted as a PR and merged, you can then go back and remove your forked version and depend on the now newly published version. Remember, you don't have to wait for a binary; you just have to wait for the PR to be merged. So there are a few ways of doing it. They sort of correspond to the difficulty of the problem. Obviously, if there are genuine significant differences between dependencies, then that's something that has to be fixed. Someone has to do the work, someone has to upgrade the various projects. I just make it as easy as possible to have access to that and to contribute back, and hopefully make the whole ecosystem a little bit more fluid and adaptive by allowing or opening that possibility up to everybody and making it as easy as possible. Publishing is, I've hinted at it already, publishing is as simple as checking for consistency, tagging with Git, and pushing to Git. And I suppose telling people that the repository exists and that they should use it. That's kind of all there is to it, but I've reduced that into a single command, so it's just one command and you've published. It's potentially able to reduce the publish time from 61 days to later that same day. If you're waiting for somebody, you just go and publish it yourself. You fork their overlay and you publish. Cross-building is a really big issue. I'm not going to go into too much detail because I haven't worked out the precise details, but essentially I will offer different schemas for different, subtly different views of the same project. And the interface has, the command line interface has a way of allowing you to modify those as you would like. Obviously, some changes you want to make globally to all, like if you're adding a new module to your project, that module probably needs to exist for both Scala.js, Scala Native, and Scala, and for all different versions of all different versions of Scala. Whereas if you're adding for example, Scala 2.13 specific, like a shims source file, that's a change you would only want to make to one schema. So the command line interface, when you decide to fork into different schemas, I'm trying to design it with the right ergonomics that it does what you would expect most of the time, or all the time I would hope, and allows you to make changes either globally or to specific schemas in your build. The big unknown for me at the moment is how many projects I can actually build with this model of build. It is difficult to answer without actually trying it, and that will happen over the next month or so. I will start to try converting projects like Shapeless. Maybe I'll even attempt Scala test, which I think has one of the most complicated builds there is. Things like code gen are going to be problematic. I need to find a way of supporting code gen. That's a possibility, but it might be that I have to give up at some point, or maybe even just temporarily give up and use binaries for certain projects. That will remain an option. You can depend on Maven Central binaries and able to download them with Corsair. Installation is pretty simple. If you're working from a command line and you have curl, I've got the fury.build domain name, so you can just pipe that into shell, and it will install. Except I haven't finished it yet, but that's how it will work eventually. And are you ready to see a demo? Have I talked long enough already? So, can you all see the screen up there? Is it big enough? I can't actually easily go much bigger. So, I'm going to start a new overlay. We're in Buildo, who are hosting tonight, so I'm going to call that overlay Buildo. And start by just creating a new directory. Let's start Fury up. So the Fury is now running in the background as a daemon. I've got an empty directory here, so I'm going to just initialize a new overlay. So I can press tab there, and it gives me a few options. These are the options you get for an empty folder. And I'm going to initialize it, and I'm going to specify a compiler, and I can use tab completion here. These are the compilers that I've got installed on my system. So let's use Scala 2.12.5. That's not quite the most recent version, but it's quite recent. And then I want to specify a name for the overlay. So the overlay, I'm just going to call that Buildo. And I'm going to start a project as well. So the project is going to be called Well, everyone starts with a pet store, don't they? So let's create a pet store project. And that was, did you see how quick that was? That's initialized a new build directory. It's actually created a new Git directory in this folder. And if we look inside, we can see there is a new file called overlay.fury. I'll give you a glance at that. The intention is not that you modify this file yourself, but it's readable. It is very diffable. So because we're making changes to this file, generally just this one file, and committing them as diffs to a repository. Okay, so committing the changes to a repository. Viewing the diffs is important. So it looks like this. It's basically a tree structure, and this contains the information that describes the build. So that is 63 lines for a blank one. Now it's initialized, I have a few more options available to me with Fury. Tab completion gives me a dynamic list with more options. So I can look at the project and show what projects I've got available. So I've got the pet store project, which contains one module. You get a module, you always get one module, which is called core. That's all we've got at the moment. I can show you the modules as well. That's what they look like. Normally, by the way, it looks like that, but I'm running it in inverted mode, because I think it's probably a little bit easier to read that way. So notice how every command I run returns instantaneously. It's fast. Now, having just one module is not very interesting, so I'm going to add a new module. And for the new module, I can specify some details. So let's call it macros, and let's specify the compiler to be. We'll just use the same one. Now, you'll see that after making that change there's now a little asterisk there, which is because the Git repository has some changes to it. So nothing is committed at this point. It's just modifying that file. So if I now do Fury module list, we can see there's now a macros module. If I do a git stash, we're back to the original state. And I can get that back with stash apply, and we're back to where we were after we added that module. So just to give you some understanding of what's going on behind the scenes. So from these modules, I want to create a dependency between these. So I'm going to say, I'm going to update a module. I'm going to update the module core. Now you see tab completion gives me the modules available. Core is the one I want to change, and I want to add a dependency. Now if I press tab here, I get the options that I can depend on. And we can actually refer to it by project / module, or just the module, because it's in the same project. So I'm going to just say macros. So our core module depends on our macros. The macros have to be compiled first. Does it all make sense? And checking this again, we've now got a dependency on macros. So you see, we're constructing the build step by step, running commands that change it, and we're very extensively using the tab completion to discover what's possible. So the idea is that from the ergonomics of using the user interface are that you should be able to discover what features are available. And I'm hoping to have some quite comprehensive interactive help, so that if you're in any doubt, you can get information through the tool itself. So we need some sources, really. So let's create some source files. I'm just going to put everything in two directories.
Can you create it in an external? You mentioned.
Yes. Yeah. Good point. Yeah. So you can refer to sources locally, and those are local sources. You can refer to sources in some third-party or some third-party repository. I'll show you how to do that. That bit isn't implemented yet. By the way, do shout out with questions. Generally, I'm keen to be interrupted, especially if I forget to mention something. So I'm going to well, let's just specify where the sources are. I'm going to update the module update, and core will have the sources. Now, if I press tab here, we'll get tab completion on the file. But if in a more complete version that supports the external dependencies, I would probably write something like GitHub some project. I need to invent syntax for this, but probably slash and then the path to it, maybe with a tag like that. So, something like that. I need to work out exactly how that will work, but for now we're just going to refer to sources core, and then macros has the sources specified like that. And actually, let's so that those are the modules. You've got the dependency, you've got the sources listed now, the compilers. Let's just finally add a compiler parameter. Let's do is it X future? So we've now got the X future parameter there, and it will check that you're using valid parameters. So we've set up a small structure, and it's all self-contained at the moment. I haven't depended on anything externally, so maybe I want to depend on something else. I'll just show you the universe. The universe gives us, or the universe command gives us a few other subcommands. I'm going to look at projects, which lists all the projects that are available to us. Now there's just one, it's the one we just set up. So not surprising because there's nothing else there. If I import a universe from a repository, now the repository I'm going to use is one that's actually online. You can view it. It's dependencies/overlay. GH is a shorthand for GitHub. You can use BB or GL for other services. I can add more if people want them. And if I hit that, if I give it that, it will then go and clone that repository. The repository is inside the .fury directory, in there somewhere. Yeah. And it's sort of hidden from view. It all happens behind the scenes, but I do at least tell you that it's that the Git is doing that. Now, if I check my universe again, now I've done that import, I've got a whole load more projects here. These are things that are in the propensive overlay. It also lists the license.
You have a dependency to another Fury build, not to code. When you added the dependency,
Yeah.
you specified GitHub repo.
I
contains another build. Not
It does.
the real code.
Right, correct, correct.
Also the code, but
Correct. Exactly, yes. So it contains, so I refer to a repository that contains an overlay.fury file. And then it will import that into the existing overlay. So that will make available all the projects that are in there. I could also potentially specify a branch of that repository, a tag or a commit hash. Those are possibilities. And you have the possibility of also upgrading to the most recent versions of those if you want to. So Pet Store is the project we created, and then these three plus this one here are the ones that are imported from the propensive overlay. And what I can do now, I can I can depend on one of these. So I've got my oops. I've still got my pet store project here. With my modules. I can update, say, the core module to add a dependency. Now if I hit tab again, I get a list of everything that's in my universe that's available to me. This is everything I can possibly depend on. I want to depend on Guillotine core. Modules depend on modules. You don't depend on projects, by the way. That's done. We can now see that core depends on both macros, which is in the same project, and Guillotine core, which is an external project. So having done that, I actually want to build this. Now, let me first create some source files. So I'm just going to edit this file in the simplest way possible. So create an object there, and here. Okay, so really basic source files, just so we've got something to compile, otherwise it will do nothing. And if I then go to build, I have some options. I can generate a list of files. Now if I just hit compile, it would start compiling. It would do what it needs to do, compile the code. I'm going to show you step by step what happens, and also sort of fill in some blanks where it's not implemented yet. But if I call generate, remember instantaneous again, we now have a folder called bloop, which contains build definitions for everything we might want to build. And I'll just show you one of these. It is JSON, and it contains references to the various things that bloop needs to know in order to do the build. I haven't got bloop integration working fully yet. So if I were to run Fury build compile, what that should do is fire up bloop, start running, and give me output. Instead, it gives me the command I need to run in order to get bloop to do that. So all I can do is pipe that into exec. And why didn't that work? That was working not long ago. Okay, exec just wasn't doing what I thought it. Is that not what exec does? Nobody knows. Okay. So if you copy paste that, it will. Maybe if I piped into sh or something. So that's just built those two files, and it tells me where the source files end up. I don't actually need to worry about where the source files end up. The command you would run when you've built everything, because most of the time you either want to know whether the build was successful or whether there were failures. If there are compile errors, then you need to be told. If there are build errors, if it's successful, then you go and make more changes most of the time. But then occasionally you want to actually pull the file out. There's going to be commands which will be something like save dest equals file.jar, which will just save a jar file of those sources. They're all sort of hidden inside this .fury directory, which contains in here, which contains everything, all of the working space of Fury. So, let's say I've got this project here. Maybe I've added some other projects into the build overlay, but I want to share it with other people. I want to republish my overlay along with everything in my universe. So republishing will also include everything that I've imported through the Propensive overlay that I included. So I'm going to say, first of all, let's say I go to GitHub, I create a new repository. leave it blank on GitHub. And then I can say, let's just specify what that repository is. So I need to tell Fury, otherwise it won't know. And I'm going to say, let's publish it to the Buildo overlay. Is Buildo the name of the GitHub group? Yeah. Okay. So I'll pretend this will work. It won't, because I haven't created the repository. And then in order to publish that, I just call Fury overlay publish, and I need to give it a tag. Let's call it v1.0, and I need to specify a key. Now this will interact with GPG, which is set up on my machine, and I can just press tab there, and it uses the key. It'll give me the key, or a choice of different keys. And I hit that, and in the background, I don't know if you saw that, but there is, it's asking me for a password. And that failed because it couldn't push to Git, but it made some changes here. It checked that it checked the overlay for consistency. It would, in theory, it would report errors if we were trying to publish something which depended on local files which were not within the repository. Obviously, I want to publish only things that can reproduce the same output. If you're depending on things that aren't under source control or aren't available, then that's not going to be portable. I've got a signature here. There's the well, that is now signed. So that signature goes with the repository, and the repository is tagged, and we tried to push it, and it failed. So that would have been publishing. Very, very simple, very easy, very fast, and hopefully a way to make it easier for the entire ecosystem to work more fluidly. So that's the end of the demo. It's sort of a tour of typical operation of Fury, including some of the more advanced features like publishing that many people just won't ever do. Current status, I think you've more or less seen the current status. The next thing I want to do is, you saw that I imported the Propensive overlay. I had a few projects set up there, and I depended on one of them. I didn't actually build Guillotine, which is my project for running shell commands. It's for executing stuff. You get it? So Guillotine is it's not set up. But what would happen when you try to compile is Fury would know where to look for the sources. It would clone them into its hidden directory. It would generate those bloop files to refer to the Guillotine sources, and then Bloop would simply go and find those files in the directory they're in and would compile them in the right order. It's very easy for me because I can delegate all of the complicated build tasks to Bloop. I just have to generate the files in the right format, and the files represent a simplified directed acyclic graph of dependencies or source dependencies that need to be built. So it's very easy for me to enable Bloop to do that. So that's I hoped I'd have finished before we started today, but it's probably another half an hour's work, I think, to get that working. That is more or less all I've got. But I think I would like to answer questions, because I've talked for probably over an hour and a half, nearly, and you haven't asked many questions. So questions along the lines of, but can it do X? I would like to hear. So, fire away.
I do have a question, please. It's more really on integrations. Since you integrate with Bloop, I guess you have thought about integrating with BSP.
Yeah.
BSP work.
So BSP is on my agenda. Actually, the reason I haven't got, I'm not building directly with Bloop through the command line. Why I just return that command, then you have to copy paste it and run it. Is I've got some strange interaction issues with the shell process that I haven't worked out yet. So when you run it in watch mode, where Bloop will watch the directories and then whenever you make changes to the source code, Bloop will recompile. Which I could, if you haven't seen it, I can show you here. So there's the Bloop command. If I add -- watch, that will watch the directories, and in another window, if I show you both at once and make this legible, hopefully if I then modify macros to just change the name of that, for example, you saw something change down there, and it was so fast that it was gone in an instant. Let me show you how fast it is again. Let's change this one. Watch up there. There we are. That's compilation. So Bloop, this is the benefit of Bloop from my point of view. I don't have to worry about performance. I'm not a particular expert on making things fast, but Bloop has had that time put into it, so I can just delegate. So BSP would be a way for me to trigger that build without going via a shell process, and I think it would allow me to get events coming back to tell me when the compilation is complete, and then I could report those, rather than just forwarding streaming output from the shell process.
You will be both consumer and a producer of BSP, so you will be a client as well.
Yeah.
Because you can provide the build structure information that SSP may need.
Yes, I need to look in detail at the BSP proposal, but I think the client-server model is in both directions very much. Everything is a client, everything is also a server. Any other questions? Yeah.
You say that it's basically a package manager, right?
Yes. A package manager that relies on Bloop to do the building, the compilation. Yeah.
So will it never end up like global packages?
Sorry, say that.
Will it never end up like global packages?
Global packages. You mean non-Scala?
No, like for the whole user or system or whatever, instead of only like imaging command line app that want to available for the whole system instead of only as a dependency for my application or whatever it is. I'm thinking about more on a package manager way than
So it seems like it probably seems like it works like a package manager more than SPT, which is probably the right impression to get from it. It's a package manager which also allows you to publish as well and gives the interactions for constructing your own builds. I anticipate it being used by all different versions of Scala, Scala 3, previously known as Dotty, Java as well, and I don't know if you noticed that if I list the modules, you can choose the compiler, so you can choose the Java compiler there if you want to compile some Java sources, and that will just work. Likewise, the compiler might be Scala native or Scala JS. Potentially, I could put other things in there. I could support other compilers if they have the same model. I wouldn't use Bloop for other things. I don't think. But it's quite capable of maintaining the graph of dependencies and dispatching work to different tools, such as Bloop. I wondered whether it might be useful to have a JMH compiler. I know that when I've used JMH, you have to create a Maven file, and it all seems like the sort of process I've gone through 10 years ago rather than in 2018. I don't know if anyone's used JMH for benchmarking, but with this, I would just specify a directory that my JMH source is going to be in, specify JMH as the compiler, and it will go and do all that work with Maven as necessary with the Maven plugin, and would generate the right commands, and then it would allow you to run it. So running code is also a possibility with both Bloop and Fury. If there's a main file, you'll be able to run that from Fury, or you can run a module.
Another question on Fury itself. Since you've been using it for your own, some of your projects, have you hit something that you could import from an SPT build, or something that you did work around that is significant to you in your workflow?
Yeah, so it's possible for someone to written an SPT plugin for extracting Bloop builds from SPT builds. It finds all the submodules and will extract, create the build files in the same way that Fury creates those build files. I'm not an expert with SPT, but I could probably take that plugin and modify it to generate, for example, Fury commands, which you could then run. That would be a possibility, and it might be an easy way of generating the builds. I've no idea how well the plugin works. I've used the plugin to generate an example file, an example JSON file, which I then modified by hand to do what I wanted it to do, and then from that example I automatically generated all of them. So does anyone think that there are, you probably work with builds, is there anything that you think this wouldn't handle, it should handle?
A project I'm working with essentially has a version set dynamically, so that whenever I publish, it's set by Git using some kind of SPT Git plugin, I guess. And when it's published locally, it instead uses snapshot version.
Okay.
Like usually snapshot, because I want to think of the native version that I publish locally.
Right.
So something like that would be
So
not crucial, but
well, I think that's very much within the model that the local publishing model, which I don't really have. So I always thought I was doing it wrong before, because if I'm working on half a dozen of my own projects at once, which is what I'm doing with Fury. It's very modularized. I've got probably 12 different projects of my own that are tiny little modules which I want to publish ultimately. But if I were doing that with SPT, each one would have its own SPT build, would have its own version number, and I would have dependencies in one build referring to the locally published version of another while I'm in development until I'm prepared to publish to the world. And I thought I was doing it wrong, that I would have to go in, change the version number manually, and maybe there's an automatic way of doing that, but I would have to change the version number in one project, publish it locally to my Ivy cache, and then in another project I would have to update that. And if I had transitive dependencies, I'd have to go through the whole chain. And because I'm trying as hard as I can to favour modularity rather than like bulking everything together into a single project, the maintenance work in sort of maintaining those links is huge and really frustrating, especially if I'm making experimental changes in one project and wanted to try them out somewhere downstream. That was something I thought I was doing wrong, and then I spoke to other people. I spoke to Olaf at the Scala Centre. He said that's how he does it. That's how it is. And what you said sounds like it's
one of the projects.
That is, yeah. I mean, maybe the automatic versioning is helpful, but it's still manual in two different places. The Fury model would completely throw that out because you don't have binaries published. Everything is done by source. If you were modifying something, if you wanted to work on two projects locally, you would start off by maybe pulling in an overlay, which contains the things you also depend on. And then, like I said, with one command, you could pull a project you depend on, pull the source of a project you depend on out of your local build, and fork it. Sorry, out of the managed directory, and fork it. And then when you have Bloop running in watch mode, it will notice changes in either repository. It will just recompile everything instantaneously. Well, it's not quite instantaneously, but as fast as you can hope for. It'll recompile everything in the tree that it needs to. It will know what's changed and what needs to change, and the whole local publishing challenge just goes away. And then when you finally got something that works and you're not going sort of back and forth between different projects, you publish or PR back to the original project. So it's a bit like I think Eclipse used to have this concept of working sets. I used Eclipse 15 years ago, and it had this before I went to Vim, and it had this concept of working sets where you could have several projects which are your currently open workspace, and it would be able to notify, or it would notice when you made changes in one and that affected another, but they were kind of separate projects. This is a similar sort of thing. It removes the friction of working on different projects at the same time. So hopefully, I hope that will be quite a lot better. More questions? Criticisms?
Maybe trivial question. Fury is based on the assumption that you have access to the code of your dependencies.
Yes.
Is there a chance to use also binary
Yes.
artifacts, like something coming from your code and something, I don't know, a strange library, you don't have the code. Published on Maven Central.
So yeah, I want to have the option to depend on binaries, either on Maven Central or just a local jar file. The interface will be just a command, which will be something like Fury. Maybe it would be as simple as module updates, add dependency, and then you would write something like local file or jar, or you would do that would be something like that if you wanted to depend on shapeless. Something along those lines. I don't know exactly what the interface would be, but I think I'm going to have to provide that maybe as an interim measure, because I won't be able to support all kinds of builds straight away. The model is going to probably evolve for a few months as I work out the best way of representing the various different builds out there. CodeGen, I think, is going to be an interesting case. I think I might support CodeGen. Well, I think quite a few projects do it. Scala Test does it. Cats does. Okay. So what I would love to say is don't use CodeGen, write a macro. But I think that's probably possible. It's probably possible to do it that way, or to use a compiler plugin. But that's probably a harder solution than just generating the source files and then compiling them. So I think what I might allow is if you can compile some Scala source, which when you run it, will generate the sources. Those sources can feed into a later phase. I think that should be permissible. it's not going to be it's not going to be a particularly nice solution, but it's if it enables it, then that's what I'll do.
I didn't get the current state of the art and local development is already published.
It's not available yet. You've just seen the world premiere of. I've not demonstrated this to more than 2 people at once before, so and a couple of these things weren't working this morning. So it's very much in development. I have an audience with Martin Odersky in New York to demonstrate it to him. So my target is to be a little more impressive than this. And maybe show how easy. Maybe by then I'll have a few open source projects converted, and I can actually demonstrate just putting them in and building everything. One disadvantage people might think of is that with source dependencies, I have to build the whole world before I can do anything. I actually think that's probably not that much slower than downloading from Maven. If you're not using Corsair, Corsair will beat it, but. Bloop is so fast, and I use Bloop for building Fury. So before Fury existed, I was using some handmade Bloop configuration files, and just having Bloop continually in watch mode. Whenever I change any of my 13 projects, you're just going to recompile stuff, and I can. My workflow with Bloop by itself is actually quite pleasant. It's more pleasant than SBT. The only difficulty was writing those JSON build files, but it's more a matter of just copy the one you worked on last, change the dependencies, change the source directory, and it works pretty well. Even for a project which is not really designed to be used in that way, it's designed to be integrated with other tools. So I'm very impressed with Bloop, and especially the speed. Yeah.
I have a question. It's linked of your premise, the release of new Scala version and then 2 months. In this particular example, it depends on EU team. And,
Yes.
How do you create a new Fury build file for EU?
Okay. So say that I'm just thinking through the process. So say the build has been produced for let's say this is not the pet store. This is actually Guillotine, which has some macros and has core, and the compiler is set to Scala 2.12.5 and 2.13 is released.
Okay.
And Guillotine is my project, but let's say I'm somewhere else in the world. Nobody knows where I am.
You're on vacation.
Yes, something like that, and someone wants to use Guillotine with 2.13. What they would do is probably let me just close that one down, and what I can do is go into the prependsive overlay, and if I show you the projects, this is what I basically published earlier to Git. This is my own local working copy. I published it to Git, and then I pulled it back in from Git. This is actually not referenced by the build overlay you saw before, just for clarity. And someone else could clone this. So let's say this is my local. I'm not me anymore. This is my local cloned copy. What I could do is I could create a new cross build. And I've no idea if this works anymore because I've changed a few things, but I can say schema duplicate and duplicate it with the compiler Scala 2.13.0M3, and the schema is going to be called, I should get tab completion on that, 2.12.13. And I could then, this probably won't work, but I could try to generate it, try to compile it. There's actually no source files because I'm not referring to them yet. Let's say that worked fine, And I've got a list of schemas here, so we've now got the 213 schema as well. Oh, actually, so you notice that I duplicated the schema, and then I ran compile, and you may have noticed that it pointed to 212. This means this is the currently selected schema. So I want to select 213 now, and if I do that list again, and then if I compile, it's now pointing to the right version. Anyway, that was all I really needed to do, and I can then publish that. This is going to be version 1.3. I think I've had several versions before, and using the key, that one, and it's going to go into the tag, and that one's actually just pushed. So it didn't ask me for the password because it's already got my password in memory. The repository exists remotely, and it's successfully pushed this time because that just worked. And then if I go, so I've just published for 213. There we are. That was easy.
Okay. So you basically copied the schema and
Yeah. So I can give you a little bit of an overview of how I anticipate the schema's working, but this may well change. So you would have a 212 schema, you would have a 213 schema, and let's say, essentially they're the same apart from the default compiler. So there's 212, 5, and 213, 0. Oh, by the way, I also might want to add a new compiler, which I would do with config, and I can add a compiler by specifying the home directory, which will be something along here. You can see I still have this compiler hanging around. I think I just specify that. It doesn't recognise it because it's 210, but it supports 211, 212, 213 compilers. So maybe you want to add the compiler first, just to check the. You have to install that yourself. Maybe I'll offer a nice way of just downloading it from the expected place. I've got what point I was going to make. Oh, the schemas. So my observation is that builds that target different Scala versions or different platforms are generally the same, apart from a few tweaks. So the tweaks sometimes include different sources, like additional sources, or maybe fewer sources. In the case of, for example, Scala.js, they include a whole different universe, because you've got the JavaScript universe rather than the Scala universe, the JVM universe. And a different compiler. Maybe a few other dependencies are different, or maybe some modules are not included in some versions. But generally speaking, the builds are the same. And if you have 8 or 9 of these, because we're supporting an increasing number of different compilers, we don't want to have to change things 9 different times in order to support them. We don't want to have separate builds for everything. There is value in cross builds rather than just me saying, well, write 9 different builds for all the different combinations. So I think what I want to do is have I've got 2 possible models and I haven't decided between them. The one that's implemented at the moment, or partially implemented, is that whenever you fork a schema, you fork from the current one and it just takes a complete snapshot of everything that's specified, and it adds another chunk to your build definition. With a different choice of a default compiler, and different schema in the universes you depend on. This is fine. You've now got 2 more or less identical copies. What I want to do then is allow you to make changes just to one schema at a time. And any change you make, you must specify either the schema you want to change or that you want to change all of them at the same time. And I'm going to impose the rule that if you try to change all the schemas in the same way, or the particular property of all the schemas at the same time, but that thing you're changing is already different for all of them, then you're probably doing the wrong thing. You're probably making a mistake. So you have to go back and first unify them, and then you can change everything at once. So I'm being conservative in what I allow to be done easily. I don't want to make it easy to make like global mistakes that can affect everything. But again, the ergonomics or the user experience of that needs a lot of practice, and I need to experiment and see what works best. The other model I have is a tree-based schema, which to me sounds a little bit like complexity. I would have like a root schema, which is the one we change, and then modifications which trickle down from that. So maybe you would have the root version, modifications for Scala 2.11, 2.12, 2.13, and then each of those would maybe branch into native JVM JavaScript. But I don't know exactly what would work best. That's something I'm going to experiment with, and I'll probably learn a lot when I come to try implementing other people's builds. Did that answer? Yeah.
Thank you.
Yeah.
Yeah, I wish on that. Given the fact that you just for now just works with other overlays, as you said.
Yeah.
And given the fact that probably you can't force with this space maintainers of most popular libraries to adopt your
Yeah.
system, could be a nice thing to provide like a repository for that gives wrappers for compiling most popular libraries.
This is sort of what I have planned, but it wouldn't be wrappers, it would be re-implementations. So I'm taking it as not. So I could, in theory, wrap SBT, but there's so many things that go on in SBT that I don't understand that I'm taking the opportunity to just throw that out, have a clean, fresh start, and re-implement all of the builds from basics.
Yeah, that's what it was meant like.
Yeah, but meanwhile, I anticipate that everybody will carry on using SBT for the foreseeable future. I'm not looking to replace SBT, because SBT will also do things like it will build images, and it will update headers in source files. It'll run Scala format. My goal is not to ever support those sorts of things. I will manage graphs of dependencies. I will maybe allow you to support different compilers. I don't really want to have a plugin interface. I think a lot of people think plugins are like a standard feature of any build tool. I'm actually quite happy with sort of the Linux kernel model rather than a microkernel model, where I'm not trying to provide a globally acceptable abstract interface that anyone can plug into and do anything. I'm going to say, if there's some feature that needs to be supported, it's a pull request to modify Fury that has to meet certain standards and has to be fully integrated in the whole tool. Because there aren't that many things that people want to support. Right now, Fury is 1,500 lines of code. It's not a huge project. The code is quite dense, but it's not a big project. If it grows to 10 times its size, it's still a reasonably small project. It's still quite a lot smaller than SBT. I could actually encapsulate a lot of the potential plugins for almost anything people use in the core compiler. In the core build tool, without ever needing to worry about external interfaces, and without needing to worry without worrying about losing control over what external tools can do and then having to forevermore support them when I want to change things. I'm happy to say I can't do stuff, or I'm not supporting stuff, if it buys me a lot of confidence in how it works. So I'm confident that the data structure is much more understandable than, for example, an SPT build. I think I've deviated from the question you asked. Can you remind me what it was, and I'll...
No, it was like, in effect, it's comfortable to have to manage sources. Like, you don't have to wait until the data maintainers decide to release the new version of the software.
Yeah.
Scala.
It means everybody
You
can...
provide like the overlay for that external library, like when you ship this to be compiled,
So
Not a wrapper, but like-
absolutely, that's the plan.
like
Yes.
a porting of the SVT scripts to your.
So I will port the builds for common projects like Shameless, and if I can do the top 20 projects, that's already significant.
The difference in this case is that you are the maintainer of that. Instead of the original author. The difference is just that.
Yeah, I've become the maintainer.
You or whoever does that. So it's not the original maintainer, but
Yeah,
another contributor.
and that's my goal, to open it up to everybody to publish overlays. Maybe there needs to be some sort of hub where people can find out what overlays are available. I would anticipate that a project like Cats or Shapeless would say you can use this overlay. If you're using Fury, you want to use Fury, you can use this overlay. This is a maintained overlay, and it's supported by us. It's not in our build, but it's not in our repository, but it's trusted. And I would hope that it would, having everybody as possible helpers to improve the fluidity and the release of builds. I hope opening that up to everybody would mean that things get changed and updates roll out a lot faster. And just give you an example of what's involved with dependency management. Large companies, I worked for a bank that uses Scala a few years ago. They had a team of people that was managing dependencies. Because they had so many dependencies in their 2 million lines of code, as it was back then, they were depending on so many different libraries, that maintaining a consistent universe of versions that worked together, consistently linked correctly, was too difficult with the tooling with just tooling. They couldn't just write a build script and say go and resolve everything. They had a team of people whose job it was to maintain dependencies, and part of that job was to fork them, fork the repositories, modify the APIs, rewrite stuff, just to keep everything working together. You would send a request to that team to say, I need to use this latest version of some library X. And several days later, they might reply to say, we can't do that until this version's been upgraded in this other project. And they then go and do the work, and then eventually you would get that version. What I'm hoping to build here is opening that possibility up and lowering the barriers, so that you don't need a team of people to do that. You can actually do it yourself, if you know what the changes are. So that's my aspiration, and I really do hope that it can shake up the entire ecosystem, and that people like Sebastian, Bill, Travis, and Miles no longer have this burden on them. It's like they've done the good work of creating really good libraries, and then they're forevermore burdened by having to publish them to a schedule that the entire community is putting pressure on them to do, because they know that nobody can make progress unless Bill, I know for example, pays someone to publish the Scala test for him. He doesn't have the time and the availability to do it himself, so he's spending his money to make sure that his open source project gets out there. It doesn't seem right. Any more questions? I'm sorry, I've had a bit of a cold. My voice is starting to fail. I can go on a bit longer, but if there's no questions, then we can maybe wrap up. We done? Yeah. So thank you for listening.